In this video, we are going to prove the following theorem. The sum of focal distances at any point on the ellipse is equal to the length of its major axis. So let's break the theorem part by part. So given that sum of focal distances, so there are two foci points on the ellipse, that is f1 and f2, and they are located at the points AE and minus AE, where E is the eccentricity of the ellipse and the eccentricity lies between 0 to 1 for an ellipse. That is something which we already know. At any point on the ellipse. So here we are going to have a point on the ellipse and I'm marking it as P of x comma y. And what do we mean by focal distances is that we have to join the f2 point with P and then the f1 point with the P. So these are the focal distances. The focal distances are f1 P plus f2p is equal to its length of its major axis. So here the length of the major axis that we have taken here is the x-axis. So the length of the major axis would be a plus a, it would be 2a. So mathematically f1p plus f2p is equal to 2a, something that we are going to prove today. So we'll have f1p first. So we are going to find f1p. So f1p is the focal distance from the point f1 to the point p, right? So in order to pull in f1p as an expression, we are going to get help from the eccentricity's definition. Eccentricity E is equal to, the definition calls for the ratio of f1p to pm. So where is the m in the diagram? So we are going to draw it now. f1p is the focal distance and pm is the perpendicular distance to its directrix. So we know that there are two directrices for the ellipse and pm is the perpendicular distance from the point to the directrix line. So this is pm distance, right? So we are going to find f1p, right? So f1p is equal to eccentricity E into pm. Now the problem is to find pm's distance. So pm distance is from here till here. And we already know that from here to here the distance is a by e. How it is a by e? The length of the point from the origin to the directrix is a by e horizontally. So the distance from here to here is going to be a by e. Now the problem is to find distance from here to here. One should not get confused that it is going to be AE, because if I draw a line that is perpendicular from the P to the axis, they are not the same points. So you cannot claim this distance to be AE. So since the point is x comma y, the distance from here to here is going to be x, and so over here it is going to be x. Now the problem is to find this red colored line distance. So from here to here the distance is a by e, from here to here the distance is x. So this particular distance would be a by e minus x. So e times, what is the pm's distance that we just found out? It is a by e minus x. So now multiplying e inside, a by e into e minus xc, the answer would be a minus xc. So similarly I am going to find the distance f2p. Now to find f2p, the definition of eccentricity is as follows. It is f e is equal to f2p, and for the second foci the directrix, this particular directrix has to be used to find the perpendicular distance. So it is going to be pm bar. So the m bar is going to be over here. So this is the distance that we are talking about. Alright. So pm bar distance has to be found out. So f2p is equal to E times pm bar. E is equal E times pm bar. So pm bar is distance from here to here. From here to here, from this point to this point, the distance is a by e. Because the point over here is minus a by e, the distance would be a by e. And this distance that we already found out is going to be x. Now the overall distance would be a by e plus x. Now let me multiply e inside, e into a by e plus xc, e gets cancelled, a plus xc would be the answer. Now left hand side is f1p plus f2p, a minus xc plus a plus xc, xc gets cancelled. So a plus a would be 2a, 2a is simply length of major axis. Theorem is proved. Thank you.